heard a lot about metadata management, data engineering, ETL, whatnot. So I'll be like slightly taking you through a different journey. For next half an hour, let's listen something about images, image matches, unlocking the image match data, how that can be embedded into graphs, and how we derive the insights, and how we unlock the traditional processes, and then really help the organizations drive growth is something I'm going to talk about. Quickly about myself, Padma. I lead the AI infra platform at Indeed.com. Indeed is the globally #1 job search engine. So over the last 13 years, I worked at multiple organizations. For example, at Amadeus, a global airline distribution system, I worked as a senior software engineer and primarily responsible for providing single access point of data for all the airlines, integrating booking, flight, and ticketing data through real-time streaming technologies. Then I worked at Fractal. I led the teams in designing and developing scalable solutions in analytics space. I worked on versatile problem statements in CPG, defense sectors. Again, in Expedia Group, I joined in Expedia at 2018, and being part of their vacation rental brand, basically we led the efforts in building data products that has let us build the knowledge graphs, and we kind of derive insights from it. So there is a success story on that, and we all know what happened during COVID. Travel was like massively affected. What happened to our data strategies, our products, how we kind of were able to like really go into the journey of recovery from what we have built is something, an exciting story I'll share. And then currently at Indeed, I'm just leading the AI infrastructure. So key takeaways will be, I'll give a very gist about the analytical approaches organizations are following. I'll not bore you guys with too many details. I think everybody in the room, I think we understand one common language is data engineering and analytics. So what is the fundamental thought process in applying the analytical approaches today? How can we think better, especially given an economic uncertainty situation? A volatility situation is there. Are we really thinking in the right, putting the right strategies in place to make ourselves succeed as well as put organization in the growth trajectory? Just about analytics, I think we very well know about these 4 analytical approaches in day-to-day we apply: descriptive, diagnostic, predictive, and prescriptive. I think if we just take one common example, let's say I launched a product today, and let's say I have did some promotional branding, discounts, sales have tremendously grew up, okay? Being part of the data engineering teams or analytics teams, what we will be asked day to day is what has happened, So as part of descriptive analytics, what we give is, we give a report of what actually has happened, market by market, slice and dice of how the sales, like exponentially grew with the discount strategies and all. In diagnostic analytics, a step forward, we just analyze what was the influencing factor for that. We kind of apply some correlation analysis, statistics analysis. Predictive is more about what is likely to happen. Okay, this season I applied some discounts. How is my sales forecasting of sales is going to look like if I continue the same discount strategy? Okay. Prescriptive is about you just take all the possible combinations, permutations and combinations, and you just suggest the business of what is the possible path that you need to take or optimal approach you need to apply in every market. So in all of these analytical approaches, if you keenly observe, we are kind of modeling around the known data, okay? Which means, let's say I knew the very fact that there is some discounts that have been rolled out, sales tremendously grew, okay? It's a known pattern around which I'm applying my analytical approaches, whether it is descriptive, predictive, or prescriptive, or diagnostic, okay? Think on the flip side. Let's say there is a fluctuation situation in the market. The best example is COVID-19. Okay, whatever the philosophies you applied or mechanisms you applied, that may not like really be valid anymore. Okay, all the features you build, all the analysis you did is just going to be like, you just need to throw it out. Okay, and you need to like just reinvent the wheel again and try to begin from the scratch, analyzing how the consumer philosophy has changed. Okay, so I think fundamentally we have been just stuck here over the last 2 decades. In the space of analytics, many things have transformed only in terms of like applying better technology, which means if I have massive volume of data, if I have to apply predictive analytics, Spark is the best choice I can take. Maybe before that we were applying some talent or like some warehousing technologies. It's only the technological evolution that has been happening, but if you have to really think beyond and see the unhidden patterns, I think there is different tooling or different mechanisms that have to be applied. So the burning question is this: are we able to drive revenue growth during the business during economic uncertainty? So aligning to that, I'll talk about this business challenge we addressed at Expedia. So Expedia is, many of you are very well aware, it's globally #1 travel company. It's a conglomerate of multiple brands, like Worko.com is a vacation rental brand, Hotels is like for the hotels unit, and then brand Expedia is known for flights and then conventional lodging. So there is like a couple of use cases in the organization. For example, in a marketplace, if as of today, if I kind of foresee that users are booking a lot in Florida region, there is one interesting use case from the organization. Are we like enough on the supply side? Are we having enough inventory to support the customer needs or traveler needs? Okay. If there is not enough inventory, how can I acquire the inventory? That's primarily the first question. Second question is, as I said, since it is a conglomerate of multiple brands, a vacation rental unit can be listed on conventional lodging system as well as on the Worko.com system. Okay, so there is a possibility of deduplication or duplication of the properties being listed. So I need to like resolve this problem. Entity resolution is one of the use case. Deduplicating the properties is one of the use case. As most of you might be aware, vacation rentals is a major business in US region. Okay, people just rent out the properties and then they make business out of it. So if owners are sort of listing in multiple sites, we have to really track what is the background for it. On conventional lodging, they might list it for $200. For Worko, they might list it for $250. What's exactly happening? Okay, so is it the property owner has changed? What has really been happening? Why the owner has listed like with two different prices? Price fluctuation is there. So these are some of the common problems that are at an odd level that were identified. And the objective for us is, as you know, when we get this property list from the brand Expedia, Worko.com, it's like different identifiers. You need to like basically, if you have to literally say that this property listed on Expedia is something that is matching with a real estate vendor, I need to have a mechanism where I can match the properties. Okay, so we have applied multiple techniques in the matching space. One is image match, other is address match, and then there is a registration number match. So simple example I would say, let's say you go to makemytrip.com, you see a property, okay? And then similarly you have Magic Bricks in India, right? Which is a real estate website where properties are listed out for sale. Usually in US what happens is, let's say I from Expedia, I see that in a particular market, there is a possibility for me to acquire inventory. I see that user demand is more. Okay, I can catch hold of the real estate owners and then reach out to them. Hey, I see that your property is listed out for sale. Are you interested in posting it on Expedia.com? Okay, so that's the kind of business Expedia runs. So if I have to really, bring this metric of how much, exclusive inventory is there on the real estate, which is not on my Expedia website, I need a mechanism to match the properties. Okay. Similarly, if I have to give the analysis on how many duplicate properties are there with my Verbo, hotels.com and Expedia.com, I need to have a matching technique. So we applied image match, similarly address matching techniques. For images, we used perceptual hash, which is a hashing algorithm. So the beauty on this is when we applied different matching techniques, we arrived at different information coming through this applied match algorithms. Let's say I take an Expedia property, I match with Verbo.com. I have 10 images here, 12 images here, indoor images match, outdoor images match. And basically from the algorithmic standpoint, it says that yeah, this property is matching with this property with maybe 65% level confidence. That's one record of entity for me. Similarly, from address match, let's say I have Expedia property, it is matching with some public records, real estate data. So I have a match there. So if you look at the the kind of matching we applied, it is multidimensional, which means yeah. So this very well explains need. So a property on Verbo, property on Expedia, property on real estate are like matched through different techniques: address, image, registration number, calendar, all that. Okay. So if I have to really get a collective view of how many properties are today exclusively on the real estate, which are not on Verbo, which are not on Expedia, I think traditional mechanism is just to apply a bunch of SQL joins and then arrive at this exclusive metrics. So what we did differently is we applied Spark graphics. Okay, so I have these Verbo properties, real estate properties, Expedia properties, hotels.com properties. We generated vertices, edges. I think the framework actually gives a way to define that. And once you get the the outcome from these different matching techniques, we just fed that information to a graph, and we got a graph. Okay, so this is an in-memory graph. So from this in-memory graph, what we did was we kind of extracted the connected component. So this is basically a component in a graph. So what this says is that, let's say there is a property on Verbo.com, a vacation rental brand of Expedia, matched with a real estate property through image. So there is a link there. Similarly, Verbo.com property matched with Expedia through image, there is a link there. So similarly, real estate property with Expedia.com property, it matched with the address, there is a link established. So basically, this gives a signal that these three properties are in a way matched through one or the other matching technique. Okay, so how this is really helping us means, as I said before, if I have to really look at in a siloed fashion how many matches we derived through images between these two entities, through addresses for these two entities, it will be like a permutation and combinatorial problem. So the graph like easily solved that for us. So now from this, it's an easy thing for us. So once we applied a graph, it gives a component ID, graph ID basically. So with that graph ID, we will be able to extract all those properties that are linked through some or the other way, through the image match or address match. Now it is easy for us to extract the insights like, hey, give me the list of properties on the real estate property surveys which are not on Expedia, not on Verbo.com. Okay, so I can just get a flattened view out of it. Joining back with the original data set and then provide those insights to the business. So a little bit about image match. So this is what I'm talking about. Like we have 2 million properties on Verbo. Real estate, we have like 4.8 million. Expedia conventional lodging 0.23. So overall, like images, if you take 91 million, 114 million, 6.3, we just matched properties with Verbo with analysts, Verbo with Expedia, analysts with Expedia, like that, like so multiple combinations. Okay, so wherever like we found the matches, those were like really a duplicate entry. So further to the image match, what we did was, so now when we derived matches, the most important question that we had was are these matches like really precise? I'll give you one example. This is one of the properties, a condos property listed. You can see that usually this is what we see normally when you visit a Make My Trip or like Magic Breaks. If owner is owning two properties in an apartment, usually the outdoor common photos will be same. for those two properties. Only bedroom photos will change a bit, right? So the indoor photos will be changing, but outdoor photos will be same. So what happened was when we applied the image matching technique, this is the issue. You see that this property has got two different, so this is one unit and this is a different unit having the same outdoor photo, okay? But the bedroom photos are different, okay? So if you have like, the owner has listed 12 photos, out of which 8 are all common photos, outdoor photos, only 2 of them are indoor photos. So the indoor match basically normalizes the complete image match score. So it used to get tagged as this property is a perfect match with what you have on the real estate inventory or what you have on the workboard.com, but which is not the case, okay? So the owner has maybe like listed like common photos, or maybe these are like row houses in a beach, all of them have a same corridor photos, okay? So for the refinement, we applied, the data science technique, which means now on the property images, we applied a matching technique, we got the image match score. Now we know that these two properties match through images, and then confidence score is less, let's say already greater than 65. We took the titles of these properties, applied cosine similarity, and we ended up at like cosine similarity as one of the feature. And then similarly, we took the description cosine similarity, 11 heaven distance is what we applied, and then we took the lat long distance. So some of the features I have listed down here, like how many indoor photos have matched, what is the image match similarity score looking like, what is the description to description similarity score looking like. So further features we developed, and then we just applied a binary classification algorithm on top of this to really, that kind of signals that whether a property is really a duplicate or not, really matching with what you have on the Expedia.com or not, or whether it is really matching with the decision of the realestate.com or not, real estate site or not. So this basically enhanced the insights that we provided for the travel partners. As I said, once we give these insights to the travel partners, their job was to catch hold of owners listing the duplicate properties. If you have exclusive properties, just go and see if that can be acquired to the Expedia website. So from the data standpoint, like we were providing these insights in 3 different ways. One is the S3 bucket, another is the API-based access, and then there is a Kafka topic, stream-based access as well, as any data engineering team would do. So far so good. It's a very engineering-driven product. We applied images, matches, and closely $40+ million revenue was the product like really deriving. It was quite helpful for travel partners and the marketing teams. Okay, but the interesting story comes now. How did like COVID really change the landscape of it? I think, as we all know, like the most anticipated thing is there were no bookings on the website for quite some time. Okay, the insights we were providing for the travel partners is no longer necessary. Okay. So we were using Elasticsearch for the product, and it was alone like consuming $24K per month, which itself was like turned out to be like a liability for the organization. Okay, so at some point we were like sort of in a state to like decommission sort of certain units because the insights that derived were like no longer valid given the economic uncertainty. So what we did differently was from the image, now when we like look at the image matches, the address matches, the fundamental thing that stayed intact is a graph, right? So from properties to properties listed on workboard.com to Expedia.com to real estate properties, that graph connectivity stayed intact. So since you have the graph connectivity, what we have seen is, especially during the 2020 summer timeline, we saw that travelers preferring vacation rentals more compared to the hotels.com or like compared to the conventional lodging. Okay, they preferred properties which are in remote areas. They preferred properties which have like better cancellation policies in view of COVID. They preferred, there is a demand for staycations. If a property is listed with a staycation kind of tag, that was more bookings were seen. Okay, so I think from the graph we were able to like really extract these unhidden things that happened during the summer 2020 May to June timeline, July timeline. Okay, that helped us like really derive different sort of insights from the same connected graph. And now we are able to help the travel partners, we provided recommendations that, hey, compared to your conventional lodginghotels.com, vacation rentals is preferring better. You have like better cancellation policies from the owners. People are preferring that. People are preferring properties not in the congested areas but in the remote areas. Okay, so it's a better to target such kind of a property. So somewhere or the other you can just recover the travel. So this has been again very successful. I think some of the work that we did was also listed in Expedia's travel website. How we kind of sort of looked at things with fresh eyes in view of like recovering the travel. Yeah. So the whole theme that I wanted to mention is the real business problem requires us to understand the relationship between objects. How you look at the business will change. Yeah, thank you.